We got geometry, page 505, 7.5. And question 12. And we're doing questions 12 through 27. We're trying to see how many we can get through. This problem has Jenny is 5 foot 2 inches tall. Person here.
Heck, it's all.
At least she's not 4'11".
Exactly. And to find the height of the light pole, she measured her shadow and the pole's shadow. What is the height of the pole? Okay, and so what she's doing is she has two similar triangles. Okay, so we know that these are similar. Once we know they're similar, that means they're proportional, right? And the key here is, remember, when things are proportional, we can say this is to this as this is to that, right? And the easiest way to do proportionals is by just drawing your line and making it equal. It's just the easiest way. And so now I know that this is proportional to this as well as this is proportional to that. So therefore, now the unfortunate part is this is in feet, right? 5.5 feet.
Mm-hmm.
This is in feet and inches. So of course, we got to change those inches to a decimal. Does that make sense?
Mm-hmm.
Okay? Or at least a fraction. So we have x over 15.5 is equal to 5 and 2 inches. Well, 2 inches is 5 and 2/12 or 1/6, right? So we have 5 and 1/6, right, over 9/12, so 7 and 9/12, which is 3 goes into 9 3 times, 3 goes into 12 4 times. So 7 and 3/4, right? Okay. Now this was pretty easy to put into a decimal, right? But this is a repeating decimal. 1/6 is a repeating decimal, right? And so this might be easier just to use as fractions. Okay? If we do use them as fractions, we want to change them to improper fractions. So this is really 5 and 1/2, right? And so then we cross multiply. And this one's easy. 7 and 3/4 x is equal to. And then I have 15 and 1/2 times 5 and 1/6. Right? And if I want to change that, it's not too hard. We can change the 15, 2 times 5, right? And then add it. So 2 times 5 is, or 2 times 15, sorry, 30 plus 1 is 31, right? And 6 times 5 is 30 plus 1, so 31 over 6, right? Then we're multiplying these. And then Jordan, how would we multiply these? Top against top, bottom against bottom. Now I would love to cancel these out, but unfortunately I have 31, which is a prime number. Right? So this is pretty nasty. We have 31 squared over 12 is equal to this guy. So we're going to want to pull out a calculator now. I was hoping maybe this would be a nice, neat number. It's not very neat, is it? So, so at this point, I think I just would rather just turn these into decimals and multiply them out that way. Because I mean, yeah, this is great, and I can change this to a mixed fraction and then multiply both sides, because in essence this is 4 times 7 plus 3. 4 times 7 is 28, right? Plus 3 is 31. Oh, wait a minute. This might turn out to be nice. Because now, if I multiply this side by 4 over 31, right? And I multiply this side by 4 over 31, right? Then this 31 cancels out with the 2 that are up there and leaves one of them, right? And then the 4 cancels out with the 12 3 times, right? So we have x is equal to 31 over 3. And then we can ask ourselves, well, how many times is 3 going to 31? And we would say, well, that would be 10 with 1 left over. And so I guess that wouldn't be that difficult. So, looks pretty gnarly, but when you get down to it, it's not that bad. Okay. Notice I didn't multiply the two 31s. Notice I put them in the square form. And it made math so much nicer, right? So back in your, like my daughter, she would just straight up 31 times 31, and she'll do the math, and she'll write this big old number, and then she'll take the number and she'll divide it by 31 again. Just because it's just repetitive math, right? And you're getting to that point in your life, right? Well, that's great. She's 12 and she's, 7th grade. But now, 9th, 10th graders, 11th, 12th graders, right? But geometry's 9th, 10th grade class, right? So as you get into the geometry level, you are looking for, they're looking for you to start retaining some of this information that you have about algebra. So keeping that squares, understanding how you can cancel out a square, okay? And you notice, I don't know if you can notice that this is blue and this is purple, right? And this is, I think you can notice that this is red.
I think it was orange.
Right? and that's fine if it looks orange. But the point is that they're different colors. And you can see where I did my steps, right? Without the colors, you don't know where my steps came from. It's just all, what do you do and when do you do it? How did, I don't get it.
Most people will just start from the top, then go down. That's what I